Question 12, you're shown a graph which looks like an exponential growth. You can see if that does follow a geometric sequence that we've got a typical exponential growth factor. So what we can say is we have that upwards and dramatic increase. I'll say in Y. To find a rule for the graph, though, what I've got to do, I've got to use the 2 points. I know I've got the points 1, 5 and 3, 9.8. Now that corresponds to T1, which is A, which is 5, and T3, which is AR squared, which is 9.8. So I know that A is 5, and if I divide T3 by T1, I can quickly find a value of R. Now, when I do that, R squared is 1.96. Now, it's possible for that to have a positive or negative value, but in this instance, we only consider the positive value. So taking the square root of that, or the positive square root, we get 1.4. So I can therefore write the rule as to the n, 5 times 1.4 to the n minus 1. We can also use this figure to figure a percentage increase. That 1.4, when we multiply it by 100, it'll be 140%, or a 40% increase per year. So that's another way of interpreting this. Now, if I want to predict the output in year 8, to the 8 is 5 times 1.4, to the power of 7, and that'll be 52.7 million tonnes. In part E, notice how you've been asked to use an algebraic formula. So 1 minus R to the power of 8 divided by 1 minus R. And when we do that on the calculator, I'll need a minute to get back to my main screen. Let's clean it up a little bit. So when I process that, making sure I use brackets to group everything. You can see that I have 171.97 million tonnes of production over the 8 years. So make sure when you write your answer that you express the answer in terms of the question that you've been given.